Hello math students, today's video is lesson 3.7, I know, what do you know? In this lesson we are going to review and apply what we have been learning in lessons 3.5 and 3.6 about graphing polynomial functions. For the first three problems, I give you some information about a function. I either give you the equation, the x-intercepts, or the graph. And we are going to use that information to find out the rest of the information about each polynomial. So for number one, I have this equation. I have f of x equals 2 times x minus 1 times x plus 3 squared. I can find the information in any order. I'm just going to go down the list, starting with the end behavior. To find end behavior, I need to know what is the degree and what is the leading coefficient. So the degree is really how many x's do I have when this is multiplied out in standard form. I have 1x in my first parenthesis, and in the second, that counts as 3 x's. So my degree is degree 3. And then the leading coefficient is just a 2. So for my end behavior, because I have a positive leading coefficient, as my graph moves to the right, it's going to go up. Because I have an odd degree, the left and right sides of the graph go opposite directions. For the x-intercepts, I am going to set each of the factors equal to 0. I'm going to go x minus 1, set that equal to 0, x plus 3, set that equal to 0. So my x-intercepts are at x equals 1 and x equals negative 3. But x equals negative 3 is going to have a multiplicity of 2 because of that square. And x equals 1 has a multiplicity of 1. To find the y-intercept, I'm going to plug 0 in for x. So f of 0 equals 2 times 0 minus 1 times 0 plus 3 squared, which is 2 times negative 1 times 3 squared, which equals negative 18. And my leading coefficient is just the 2. When I go to graph it, in behavior, I go up to the right, down left. I have my x-intercepts at 1 and negative 3. And I have my y-intercept at negative 18, which I didn't necessarily have on the graph, so we're just going to say maybe negative 18 is right there. And then it's just a matter of connecting this now. So x equals negative 3 had a multiplicity of 2. So I come from the bottom. When I get to negative 3, I'm going to touch the x-axis, don't cross through. Come down negative 18, make sure I cross through the y-axis. And then at 1, I'm going to cross through because I had an odd multiplicity. And that is what my graph looks like. Number 2 is similar to what we did in 3.6. I'm giving you the x-intercepts. I'm telling you I have x-intercepts at x equals 3, x equals negative 1, and x equals 0. So when I write my equation, I have f of x equals, it's going to be x minus 3, so you always want to change the sign. Because I had a multiplicity of 1, my exponent's just going to be a 1. X minus negative 1, or x plus 1, had a multiplicity of 2, so I'm going to square the factor. And then I have x equals 0, so it's just going to be a 0, and I'm going to square it. For the end behavior, my degree is going to be a 5 because I have 1, 2, 3, for 5 x's if I was to multiply everything out. And my leading coefficient, I told you, is just a 1. So as x approaches positive infinity, that positive leading coefficient means my graph goes up. And then as I go to the left or approach negative infinity, odd degree means left and right go opposite directions. For the y-intercept, I don't even necessarily need to go and solve for this. I know it's just going to be a 0 because I have the point 0, 0 as my x-intercept. So let's go and put everything on the graph. As I go to the right, my graph goes up. As I go to the left, it goes down. I have my x-intercepts at 3, -1, and 0. My y-intercept is also at 0. So I'm going to come from the bottom. When I get to -1, I'm not going to cross through the x-axis. I'm just going to touch, change directions, come to 0, have a multiplicity of 2, so I have to change directions. Go down a little bit, come up, and that's what my graph more or less looks like. If you were to put it into a graphing calculator or Desmos, you would see that this section over here actually goes a lot further down than what I have in my graph. But as far as secondary 2 goes with graphing, all that I care about is that your end behavior, your x-intercepts, and your y-intercept are correct on your graph. If that's correct, then I don't necessarily care what the rest of the graph looks like. Finally, number 3, I give you the graph. So I'm not going to start with the function because I need to know the x-intercepts before I can write the function. So my x-intercepts are x equals -2 and x equals +2. At each of those points, I am just touching the x-axis. So that tells me I have an even multiplicity. For the purposes of this class, we're just going to always assume that if I touch the x-axis, the multiplicity is 2. So let's go and write our function. I have f of x equals, and then I want to change the sign. X, instead of being -2, it's +2. I have a multiplicity of 2, so we're squared. And then x minus 2, I had a multiplicity of 2, so it's squared. My end behavior we can either get from the function, or if I just look at the graph, both ends are going up. So I'm going to say as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. Sorry, x approaches positive infinity. The y-intercept we can see from the graph is 16. For 4 through 8, or 7, I have a description of a polynomial that we want to sketch without using any sort of technology, except for, I guess, a pencil. So we're going to sketch the graph of the polynomial function, and then it says the term double root means the multiplicity is 2. Another thing that I should point out is I'm using this word zeros. 0 is just another way of saying that I have a root or an x-intercept. At least for this class, that's what we're going to say. There are some minor differences, but we're not getting into those this year. So number 4 says I have a cubic function. Cubic, think about it as a number is being cubed. When we cube a number, it has an exponent of 3. I also say I have a leading coefficient of -2. So my leading coefficient tells me that as I'm going to the right, my graph is going down. Because I have an odd degree, left and right go opposite directions. I'm also telling you that I have 2 negative zeros and 1 positive 0. So I have an x-intercept and an x-intercept. So 2 x-intercepts on the left side of the y-axis, 1 x-intercept on the right side. And now all I have to do is make sure my end behavior is correct. So I didn't necessarily exactly go through the x-intercepts that I've drawn, but I still have the correct shape. Number 5 is the same kind of thing, except for I'm saying I have a quartic function. That just means you have degree 4. And I'm saying I have a leading coefficient as 1. So positive leading coefficient up to the right. Even degree means left and right go the same directions. I also tell you that I have 2 negative zeros and 1 positive double 0. So that means that my multiplicity is a 2. So I'm going to come from the top, make sure that I cross through the x-axis twice when I'm negative, and then when I come over to be positive, I'm going to touch the x-axis once, but not actually cross through. Number 6, you'll notice, is pretty much the exact same as number 4. The only difference is number 4 says that I have 2 negative zeros and 1 positive root, or positive 0. Number 6 uses the word root instead. Finally, number 7, it's going to have a quartic function, leading coefficient of negative 2. That means as my graph goes to the right, negative leading coefficient says I go down. Even degree, left and right are the same. I have 2 positive roots and 1 negative double root. So on the left side, I need to make sure I touch the x-axis but don't cross through. On the right side, I cross through the x-axis twice. And that is my graph.